Okay, so my name's Craig. Thanks for coming to my talk. This is a talk about hunting supply chain threat activity, specifically in cloud environments using anomaly detection. And it's a continuation of work that I've been doing. I've been working on anomaly detection and cloud threat hunting and detection for a long time now. My background is 20 years ago, I volunteered to work on detection features in a security product that was kind of like an insider threat hunting product that we might call it UBA today. Nobody wanted to do that work, so I kind of YOLO'd it and volunteered to do that, and I've just kind of been working on detection and analytics ever since. I worked on a couple of more big data, large-scale security products along the way. I spent some time at two of the largest AWS organizations two of the largest AWS customer organizations in the Boston area where I'm from, and got interested in anomaly detection there. So this is my 6th B-Sides talk. First time at Rochester though, so thanks for having me. It's great to be here. So the way I got here is these are my last few years of presentation. So the way I got here is back in the 2016-17 timeframe, I was working on security at this large AWS organization, and we had customers that, as we were working through security requirements and what people wanted us to do, we would have customers that come and say things like, well, you must have a next-gen firewall, or you must have this network intrusion detection system, or you must have this, or you must have that. Because these were their policies that were kind of like set, like carved on stone tablets, and you had to follow them. And what interested me, I think, what got me really interested is the fact that a lot of that stuff is really not that effective or even that relevant in cloud environments, because so much of what's going on involves pure services and just API level services. And yes, there are large fleets of virtual machines and containers, and increasingly people are using serverless stuff like Lambda. But apart from the virtual machines and maybe the container instances and those virtual networks, there's really not a lot of useful places to apply conventional security technology that we're used to. And even some of the host-based stuff, like we can put EDR agents and instrumentation on virtual machines and servers, but that still doesn't really help us when it comes to the service layer and the API layer, because there isn't really a way for us to instrument that apart from collecting logs and doing analytics on the logs. And that gets interesting because I'll kind of explain as we go. So, background is working on threat detection, working on cloud threat hunting and detection. In 2018, I went on a kind of a tangent. I went on a bit of a walkabout and worked on an open source SIM project using open source tools, and published all that back in 2018, 2019. And then started working on anomaly detection then, and started doing a lot more serious work on applying machine learning techniques to threat hunting and detection starting in 2019, so for the past few years. I've been spending a lot of time on that, not just for cloud threat hunting and detection, but also for endpoint and network events. But this talk is mainly about cloud, because what I found is that anomaly detection is good to have in general across all these data domains, but in the cloud world, it's really essential. So this is just kind of what I'm trying to advocate, is trying to put a name to what I do, and I'm going to publish more on this. I need to publish a longer description on this, but the reason I try to call it, well, the reason I invented the term detection science is to try and put some definition around what it means to kind of fuse together conventional security research and threat hunting detection techniques with machine learning and data science, because it's not exactly data science, because in security detection, not everything is a data science problem, and not everything can be solved by data science. Some of it can be solved by technologies and tools that we already have. And also, the goals are not exactly aligned, because the goal of data science and machine learning usually is to do really good data science and machine learning. And it isn't necessarily the goal to deliver really high fidelity, high efficacy detections to the users that need them. And of course, at the same time, not everything can be solved by machine learning either. So I call it detection science. I like to call it detection science just to kind of define this field of study. Basically, my goals are to maximize basically to get the best possible detections at the lowest cost is what I mean by resource to kill ratio. And you know, getting away from, sometimes in security practices, I think sometimes we tend to get very tool oriented, and we get very oriented around our either like NSM or EDR tools, you know, network or host data or something else. And sometimes, like especially in the cloud domain, sometimes it's necessary to kind of throw that stuff out and start over, because there's a lot of things that just don't leave network or host-based evidence in cloud activity logs. And finally, you know, it's not a product, and it's not something that can be productized. That's why I like the term detection science. The practice of detection science, something that belongs to us. It can never be productized. It can never be turned into a product or a use case or something like that. And so it's you know, it's ours. So in terms of contents, I'm going to talk a little bit about supply chain and why I'm using this theme for this presentation. There's a story behind that. We have 4 public case studies. So in terms of a quick overview on cloud threat hunting and detection, there are 4 good, large public record case studies that are out there right now. There are probably more than 4, but there are 4 really, really big ones that are well known. And then I want to go into what I've been doing in order to try to solve this for the last few years. And what I'm doing now is a little different than what I had been doing a couple of years ago, so I want to kind of show that along the way. So in terms of retro, the reason I'm using this theme is it wasn't that long ago when supply chain attacks were sort of theoretical, in that we had not yet imagined that they were possible. It was kind of a failure of imagination, is a term sometimes people throw around. It wasn't that long ago. It was maybe 10, 12, 14 years ago. I was in a threat modeling session at a large organization, and I looked, you know, looking at the data flow diagrams and the network diagrams. I said, hey, what about this? There's this like vendor. There's a lot of access via this supply chain route to this particular vendor or these vendors. And so what if somebody, you know, comes in, you know, that way, like basically rather than coming in the front door, what if they you know, they tunnel through the parking garage underneath the bank and come in a way that's never been expected before. And the initial response that I got was, because at the time it was beyond, and you know, it wasn't in our experiential base. So the response I got was, well, isn't that kind of an Ocean's 11 scenario? Meaning like it's just something that we couldn't quite imagine yet. But over the last decade, we've realized it. I think, you know, starting in 2011, the RSA breach was, I wouldn't say it wasn't a supply chain issue in that I don't think the supply chain itself was affected, but I think it was more a case of going after the authentication mechanisms. Probably the reason that somebody was going after that was probably a secondary to another objective. It was probably means to an end, is somewhere else that they wanted to get access to, and they needed to get around or get through the 2-factor auth that was in place. 2013, we had the Target breach, which, if memory served, that was I think an HVAC vendor that had that had some more access to the network than maybe was expected. And then, of course, the big one is in 2020, who's heard of Sunburst? This is probably the biggest one so far, where a network monitoring tool actually had malicious code inserted into the build system, and it was included in a build of the product that was distributed to the user base. And it was had quite a extensive impact, and there's a lot of incident response and cleanup required by that. That might be the first time that we've seen a supply chain attack of that level and sophistication, and so that was really kind of eye-opening. So, in terms of cloud threat hunting and detection, most of the time we're talking about credentialed access. Once in a while, you'll see more interesting research on. Sometimes people try to cross certain security boundaries. Once in a while, you'll see much more advanced kinds of attack research. But most of the time, in most cases, we're talking about credentialed access where somebody's credentials in the form of a key or username and password have been compromised or have been leaked or have been spilled, and they're in the hands of a threat actor. So somebody's impersonating a legitimate user. And this is not dissimilar from insider threat hunting in that I found this quote. This is I think the best quote that I found so far that sums up the problem. It was by Peter Neumann some time ago, long time ago. But he argued that a compromised user is sometimes logically indistinguishable from an insider threat is actually sometimes logically, well, what I mean rather is an insider threat that is compromised or in the form of a compromised user account is the two are kind of logically similar enough that it's hard to distinguish or disambiguate between them. And so most of the time, if we have somebody, we have a case of credentialed access where somebody is impersonating a user or somebody is just hijacking a user account, it's not dissimilar from hunting insider threat. And sometimes it's actually, it's hard to find because this is kind of the best, This is kind of the best problem statement that I've found so far. This is better than anything I've ever come up with on the subject. And the reason that cloud, like especially credentialed access and cloud activity is hard to find is that it's simply hard to distinguish threat activity between legitimate activity because the differences are usually just a matter of nuance. And I'll give you some examples of what that looks like. So the most recent example that we have that's in the public domain is actually just recently, this year, over the course of early this year and late last year, there was a disclosure by a large software provider, password manager. Anyone read about this? So yeah, this is probably top of mind. This was interesting because according to what's been published, it looks like they actually went after a developer's home system that was running a media server with, it sounds to me like, reading from what I can read, it sounds to me like they had a listening media server with a listening port that was internet facing. And somebody with, whoever the threat actors were, they were able to identify the user's home IP address and find that port and find a working exploit for that media server and then gain persistence on that developer's home system, which they had apparently been doing work from. So they were able to harvest credentials from that system, from that home system, and then use those credentials to gain access to the cloud environment. Now, whether they came from, I don't think we know whether they, when they used those credentials and did what they did, and I don't think we know whether they did that from the compromised laptop or whether they took those credentials away somewhere else. Usually you'll see them take the credentials away somewhere else and just use them directly, rather than making the assumption that they're going to be able to persist on the initial target indefinitely. In 2021 was the first time we had what appears to be an actual case of insider threat. So in 2021, according to this indictment, there was a user who was fairly privileged, somebody in engineering, who actually went rogue and started to access data and things in ways that were not authorized and took a few steps to try to obfuscate his identity. Was still using sounds like he was using his normal credentials like that he used for day-to-day work, but he was coming in from a VPN service in order to try to make it look like, or to try to probably create the appearance that his credentials were compromised in the hands of someone else. And one of the things that's interesting about these indictments is, I think without realizing it, there's often kind of a breadcrumb trail to anomaly detection techniques in these, because many of them will cite certain unusual method or action activity. Like in this case, they talk about, there's a command called get caller identity that was apparently was something that they kind of focused on in the investigation. And so get caller identity is basically like a who am I in the AWS API. It basically just tells you what your current user context is. And this was another, so in all of these cases, there's been large-scale data exfil. And many of them are similar in that they largely consist of credentialed access, sometimes some lateral movement, followed by large-scale data exfil. 2019 was the second one of these we've seen. This was a little more complicated in that in order to obtain working credentials, according to what's been published, they actually were able to bounce through a WAF service that was running on a virtual machine. And they were able to get command execution on the virtual machine running the WAF service. And then from there, they interrogated the metadata service in order to obtain some valid credentials, because the metadata service, if you're not familiar, it's just a service where a virtual machine instance can ask questions about itself, and including things like what is it authorized to do, but it can also do what are called assume role operations, where it can assume privileges in order to do transactions in various services, depending on what it's authorized to do. So they basically harvested credentials that way, and then used those credentials. They came back in from a VPN service and used those credentials to start doing bulk data exfil from the storage services. And then the first one is 2016. Anybody remember this? This is the first big case, first big public case. This one was interesting because yeah, exactly. And this was interesting because there's no virtual machines, there's no virtual hosts of any kind involved here. No virtual machines. That's not to say that of course, there were a lot of dimensions to this intrusion set, and of course there were host-based dimensions to it, and lots of dimensions to it. But in this particular aspect of it, the exfil took place just by sharing snapshots. So it wasn't necessary to try to persist on a virtual machine or a virtual host of any kind. It was just using snapshot sharing to kind of forklift data, presumably from the victim account to the attacker's account. So in terms of detection, so one of the first questions that I kind of found myself asking as I started working on this was, well, so if we know what actions are being used in order to do things like exfil and lateral movement and privilege elevation, like we know what actions they're using and we know what it looks like. So can we, how can we alert on these? Can we detect this stuff using conventional alerting? And so in these 4 case studies, 3 of them talk about specific actions that were unusual in some way. And the most recent one, we don't have that level of detail. I would speculate there was probably some privilege-related methods in there, some actions, but a lot of it was probably just S3 data operations and bulk data exfil. But in the first 3, they talk about how there was unusual or anomalous usage of these 3 methods. It was one of the things they noticed. So, if we ask the question of whether we can alert on these, or whether we can just simply alert on these, we really can't, because these actions in CloudTrail data of medium or large-sized organizations, depending on how large your AWS world is, these actions can exist in the tens of thousands, or there can be hundreds of thousands of instances of these actions in the logs for a time frame of between 1 and 4 weeks. Most of the time I don't see CloudTrail data retained longer than 4 weeks, at least not hot data. So most of the time I'm looking at between 1 and 4 weeks. So that's way too many to even think about simple alerting, obviously. CloudTrail events are even harder because this is something I'm going to work on next, because in a large environment with CloudTrail, S3 audit events in a large scale environment where you're auditing S3 access generally, down to the level of who's accessing what objects in which bucket and what are people doing, that can easily generate. The highest I've seen is that can get into the billions per week. It can even go, in some cases, even north of 10 billion events a week doing large scale S3 auditing. So, way too many to think about alerting. And in terms of, so the get caller identity method, the other reason that it's hard to try to do any kind of alerting or around this is that what I did here is I plotted the number of unique user contexts calling the method and the number of times they call it in a scatter plot. And you can see that there's a few user contexts that generate vast numbers of events calling this method vast numbers of times, and there's a long tail of user contexts that call it a few times, a small number of times. But it's a distribution that's hard to deal with in terms of finding what's unusual. Same thing for source IPs. The case studies talk about source IPs, and sometimes people will try to go down the road of alerting on source IPs or trying to make lists of good and bad source IPs or known and unknown. But that's really hard too, because just for this one method, there are a few source IPs that generate vast numbers of events for this action or method. And there's a long tail of source IPs that generate few events. And so it's well beyond anything we could think about by using any kind of a list or definition. List buckets is figured in some of these cases, because if somebody is going after S3 in order to do bulk data exfil, one of the first things they're likely to do is to do a list buckets command, which basically does what it sounds like. It just enumerates S3 buckets by name. And so that's, if we could alert on a suspicious list buckets command, that could be potentially one way to get earlier in the cycle. Maybe try to get on this before data exfil starts to ramp up or scale up. But this, again, it's a very popular, heavily used command. It can occur thousands of times a day, sometimes even millions of times a day at the high end in a really large S3 environment. And so trying to find one or two or three, trying to find a handful of suspicious instances of this in the mix is really hard. Even trying to do this through manual data sifting it's largely infeasible. Again, for list buckets, so one of the things that you might have noticed in the case study, one of the dimensions that's discussed is that commands like list buckets, so data, discovery activity like list buckets followed by large-scale exfil activity were coming from source IPs that were unusual or that had not been seen before. And so sometimes, and at first, that was one direction I thought about using was trying to do that, but source IPs have one of the highest cardinalities, meaning there's the source IP values in CloudTrail logs are one of the fields that have the largest number of unique values. And there's way too many of them, and there's a long tail of IPs that are relatively rare or unusual, but they're completely normal, just because modern networks are so hyper-distributed. So that's kind of out. There are projects out there where there are alert rules out there today alerting on some of these methods. Even things like these, like assume role is basically the way that you obtain privileges to do what you want to do or to work in a service, is you call this method called assume role, and then you get an access token that allows you to do work in a particular service. But these are some of the most heavily used methods or actions in general. These can easily get into some of these can get into the hundreds of thousands of instances, or they can occur hundreds of thousands of times per month. So it's really infeasible to try to alert on these. At least any kind of a simple alert where we're just alerting on the action was assume role or gets you good value. Even just turning them into events is quite expensive, but turning them into alerts by themselves is kind of out of the question. So then what do we do? So in the case of snapshot sharing, this one is, as you might know, this one actually has its own technique in the attack matrix. And it has a technique assigned, and the tactic is exfiltration. And so they talk about detection in here, and they talk about how, well, we can't really, because of the volume of normal snapshot activity, it's going to be kind of impractical to try to just alert on that generally. So what they talk about is looking for unusual or untrusted accounts or unusual activity. Basically, the guidance is to look for unusual snapshot activity. So then the question is, so how do we do that? Because most rule languages and most security products are search-based or query-based. And so you can write rules with searches or queries that match, say the action is share snapshot, or or the source IP is this. You can match any particular value in the field. But most of these rule languages don't really have a notion of anomaly detection where you try to compose a rule that says, show me anomalous or show me unusual snapshot activity that is very unusual from day to day. So in order to do this, The one thing that works in our favor is that at the macro level, if we draw an attack tree, the number of patterns at the macro layer are relatively small, in that most of the time it breaks down to one of these 5 routes. If somebody has compromised credentials that work in the cloud console, if they're logging into the console, then it's going to be somebody coming in via console username and password, or possibly a SAML token. If they've compromised a persistent key, like a key that has a long lifetime, then they could be coming in, they're probably coming in from, well, they could be anywhere. It could be from a laptop on their desk, or it could be a virtual machine server in the cloud, or some combination of the two. If they decide to go the other route, if they're not successful in finding compromised credentials, or they just decide to go a different route. The other route is if you can get persistence, if you can get execution and persistence on a virtual machine, then you may be able to obtain keys from the file system. If there are persistent keys in the file, sometimes keys are persistent in a file in the file system. Or you may be able to just do assume role operations and obtain short-term temporary access tokens. And then that would allow you to do operations potentially from that EC2 instance, or you could take that key away and use it from somewhere else. But most of the time, it's going to break down to one of these 5 patterns, and that one of these 5 areas is exhibiting new or unusual or outlier behavior that doesn't normally manifest. And so what I'm displaying here at the bottom is these are the actual anomaly detection methods that I'm using. So I'm looking, so many of them are tuples, or they have partitions, in that they're considering a combination of fields. So things like, for example, a rare, if you decorate CloudTrail events with geo information, so if you use something like MaxMind, then you can enrich CloudTrail events with the geo information, like the source country and the region and the AS name, and that's great because the cardinality there is very small compared to the cardinality of source IP is super massive, but the cardinality of geo and ASN information, at least normally, is much smaller. So essentially looking for things like an action coming from an unusual geography, a new action for a user that we haven't seen before, and then some standard deviation-based analyses that are looking for say the top 5 largest spikes and surges, either in errors or events. One of the ones that I'm planning on doing is a new source IP for an account, or new source IP generally. And I'll explain to you why that's, the reason that's going to work is because I think doing that over a long term, like on basically an indefinite learning period, that seems to work well. And then over here, I'm doing rare service for a user, not rare action for a user, and I'll show you why. I'm doing new action for a user because that actually has better efficacy. New role for a key is a good one because most of the time, whether it's a virtual machine or a CLI or it's automation or if it's a human, most of the time, whatever it is, entities tend to reuse the same roles over and over again for whatever key they're using. And that's one thing that works in our favor is that much of the time, entities tend to do the same kinds of work every day. Not always, because people will start new projects and start using new services, and things will change over the course of months or a year. But day to day, it's often kind of predictable. How are we on time? So we're good. All right. So this is what I've tried to do here is I've tried to depict why I'm using the combination of the 3, why I'm using functions that look for rare combinations of fields, why I'm using functions that look for new behaviors in terms of new combinations of fields that have not been previously observed, and why I'm using spikes. And so what I've tried to do here is to try to diagram what each of those 3 is good at detecting. And so in this is a simple chart where the vertical axis is event density. It's basically the volume of events for either an action or a user context. And the horizontal axis is the time frame and duration. It's because the question of whether an intrusion is new or long-standing is often relevant, because if it's day one and somebody has just begun using compromised credentials, and credential access has just started, say an hour ago or just today, then in that case, sometimes things like a new action for a user are good at finding that and finding it early, and early enough possibly to make a difference. And new action for a user is actually being really productive, and I like it because it's one of the anomaly detections that actually aligns well with the whole thesis that we see in the case studies, in that in many of those examples, we are looking for activity that is rare for a user, but in many of those examples, we're actually looking for user activity that's completely new and has never manifested before. So that's a more precise way of getting at it in many cases. However, in a case where somebody has been persisting long term, if initial access was last week or last month, or if it happens today, but we don't start doing anomaly detection until sometime in the future, in that case, then whatever the threat actor is doing may not evaluate to be new activity for that user context or that entity, but it may still be rare. Especially in the first few days or the first few weeks, you can often find it by means of the fact that the activity it's not brand new, but it's rare for the user compared to all of the transactions and work that the user does. What the things the threat actor doing are relatively rare. It tends to be more sparse. But of course, there are exceptions to that. There are exceptions to everything. So if a threat actor starts doing large-scale activity, like large-scale bulk data exfil, or one of the things that happens a lot is if somebody gets execution on a virtual machine, one of the first things they'll do often is to just start doing tons of automated discovery, and essentially just running automation to just start asking for roles and calling methods and trying to do transactions and basically just kind of playing, what can I get? So try to do everything that you would like to do and then figure out where you get, what operations are successful and what are not. So where you're successful and where you're shut down. And in most environments, when that starts happening, most of the time it will result in an EC2 instance or a virtual machine that it's trying to move laterally across services or actions that it doesn't normally use, or it's trying to access services or resources or things that it doesn't have access to because they're not part of what it does. And so in that case, there'll often be a huge surge in authorization errors, in access denied, or there are one or two others. And that's actually one way of, sometimes if somebody has just landed on an instance and is doing discovery or lateral movement or trying to do privilege elevation, sometimes you can see it first there. So that's one way of potentially finding this stuff early. But of course, like everything, there's exceptions to that too, because none of these are perfect. Because if the compromised instance, or if somebody has obtained credentials that have a godlike access to the nearly unlimited access to the account, then it's likely there'll be no surge in authorization errors. However, if they start doing large-scale automated discovery, it's likely there'll be a statistically significant surge in events for that user context that can be visible in a time series histogram. And if we have time for a demo, I'll show you what one looks like. So in terms of applying these to the examples, in this case, in get caller identity, this is coming from a rare source country and network because it's coming from a VPN provider that was just not normally used here. Also, in the course of, there was some defense evasion here and things like setting certain retention level periods to 1 day, presumably to try to keep Cloudtrail log retention down to 1 day, so that if somebody went to try to investigate what's going on, they would find that there wasn't any data that was older than 24 hours, just to try to make it hard to investigate. So that's potentially, so those operations, those are not abnormal operations, but they would have been coming in from a source geography that was unusual, coming from this VPN provider, and from a network that's unusual. And it could also be, depending on what this person does, most of the time, not always, but much of the time, environments are spun up and torn down by automation. And so most of the time it's going to be the automation account that's doing this kind of housekeeping and setup functions, like setting things like log retention and logs and all that instrumentation. And so it can be unusual for a human user to start actually working in those services and making changes. So there's another two possible techniques there. So a user accessing a service they don't normally access, like modifying the logging service, and also a new action. Like if this is somebody that doesn't normally go around changing retention policies, that would be a new action for the user. And then this one is the original example. This is kind of similar. So the question here is, why is the WAF role coming from outside? Not only is it not coming from the WAF instance, it's not even coming from the cloud environment. It's coming from a VPN provider somewhere else. So it's coming from a source geography and network that is anomalous. And the next question is, why is the WAF role accessing S3, which is never done before? So there's new action behavior there for the user context. In the snapshot example, my impression of this is that this probably would have been both a rare service for a user and a new action for a user, because from what I've read about this, it sounded like the user here is probably somebody that is not actually in the console sharing snapshots and doing things like that. So that all three of those would potentially found that. If you're wondering, like, why not just simply look for rare actions? A method in the API is essentially called an action, is what I mean by action. And the reason is that this is what the distribution of actions looks like, and it's kind of a mess in that it's not a normal distribution. It's programmatic behavior, it's largely machine behavior, not human behavior. So a lot of those assumptions break down. But there's a very long tail of outliers that are just completely normal. So the reason I don't do rare action for a user is that even in a medium-sized data set with, say, 300 million Cloudtrail events, there are too many normal outliers. If you say, show me the top 5, the top N least frequently occurring rare actions for a user, there's just too many normal outliers, because like the scatter plot I showed earlier, most user contexts, they call the same actions over and over again many times, but there's a long tail of actions that they call occasionally. So what I'm doing instead is, this is the output of essentially what this is doing is this is looking at a new action for a user. So it's looking for cases where a user has called an action today, or say in the past 2 or 3 days, that user has not called previously in the past 30 days. And that actually has really good signal to noise. With 300 million events, I only get 8 results, and most of them are actually interesting. Looking back 30 days at the moment, but what I plan to do is, I'll show you that in a moment. So the case study that I have for you is the first time I turned this on. So this is the third project I've done on anomaly detection. I was first working with some anomaly detection functions in an open source platform. I spent a couple of years building anomaly detection machine learning jobs in an unsupervised machine learning engine in a commercial platform. And at the moment, right now, for purposes of experimentation, I've decided to do that a little different. So I'm actually doing these in SQL. And rather than computing relative anomalies in a learning model, like in an unsupervised learning model, I'm actually just computing the top n absolute anomalies, like the top n most rare combinations, the top n behaviors that are new, and the top n surges or spikes, like the top 5 or so largest standard deviations in terms of surges and events and errors. And I'm actually getting good results from that. I'm actually liking the results that I'm getting from that a little bit. So the first time I turned this on, I was expecting to find just more of the usual, that like just more potential suspicious activity and more conventional kinds of threat hunting and detection. But the first time I turned it on, what I found is I found these assume role events coming in from a source country that was extremely rare, and that it had only manifested 2 of those events. And what's being displayed here is that of the 42 million assume role events in this data, only 2 of them came from that country. And of the 2.2 million described instance events, only 1 of them came from that country. And so that was interesting, because that is a country that did not have in this particular case, there wasn't a normal business relationship. There weren't users sitting in that country. There wasn't a normal business relationship with that country. So when we dug into it, what we found is, and these are just some more numbers, so there were some EC2 operations, there was 1 describe instance action, and there were a couple of others. So what I found is it was actually coming from a third party, because you may have noticed there are a lot of third-party services operating in cloud accounts now, and some of them are doing management, automation, and orchestration. Like you can outsource management of your Kubernetes instance to someone else, or you can outsource management of your entire cloud environment to someone else, or just aspects of it. Or you can subscribe to security services in order to do like security monitoring and things. And so then what happens is typically some kind of federated authentication provider gets trusted, and cross-account access gets enabled, so that the third-party provider, the vendor, is able to authenticate into the customer's account, and in order to be able to call actions and do transactions and do work in support of whatever they're doing. There are a lot, there's a number of kind of cloud management service offerings out there, and there's a number of security services out there. The reason for the reason why the snapshot events are so voluminous today compared to, say, 5 years ago is there's a lot of this kind of like agentless security scanning going on, where vendors will authenticate into your cloud account, and then they'll take snapshots and they'll just scan, they'll run those snapshots through a malware engine using YARA rules or behavioral rules or some combination of that and something else. And so there can be tons of snapshot activity. But this was interesting because it was during the course of my career, one of the things I found is that whenever I do something new, I tend to find something that nobody knew was there, and sometimes that creates a little bit of chaos, but it's always interesting. And this was one of those cases where it wasn't even really known that, I think there was maybe some awareness that this third party had admin access to this account, but it wasn't really expected to, nobody was expecting to see the vendor coming in and just doing transactions when, like, in the course of just kind of out of the blue, where there wasn't any actual, like, collaboration going on. Like, there wasn't a service request open, there wasn't a question into the vendor, like there wasn't anybody asking for the third party to come in and do this. So it just happened. And so I think, anomaly, for this reason, I think it's another reason that anomaly detection is going to be really key for this, is that without anomaly detection, given the number of third parties that are working in cloud accounts now, I think apart from without anomaly detection, I think, how are we possibly going to find this stuff? Because it's hard enough just to find suspicious activity coming from compromised credentials or credentialed access. But when it's coming from a third party, it's even harder because it's a third party, it's hard to even kind of know like what's normal and abnormal and what's expected and not. And like, is it normal for them to do this or to do that? Or is it normal for them to be coming from this network or this source geography? And trying to figure that out manually with searches and analysis would take forever. So I think anomaly detection is possibly even more important for this kind of managing supply chain risk in these accounts, in addition to just conventional threat detection. Some other examples. In the chart, I mentioned there's some geographic detection I'm doing there. So geographic detection, looking for things like a user account or a user context coming from 2 different countries or like 2 or more different countries at the same time. And that's a technique that's worked well for me generally with authentication events and many kinds of events. In the post-COVID world, it's not as reliable though, because users are all over the place, because users can and do work from everywhere, and users roam around, and like I have users that they come to the US and then they go home to whatever the country they're from, and they're there for a few weeks and they come back, and they might actually come in from 2 countries in the same day in the process. Everybody has multiple devices coming from multiple IPs and multiple networks. So in order to do this, this is another area where I'm planning on applying a new algorithm. So rather than looking for same user, multiple countries, we're looking for a source country that we haven't seen before for a user. It's something completely new. A new source IP. So new country for a user, it has an example on the top where we had a user actually coming in from, there's a case where the first result is a user context authenticating in from France, which is just a new country that they had never come in from before. And the instance on the bottom is new source IP. So rare source IP does not produce good results. You have way too many, just trying to alert on that would have way too many kind of normal results. But new source IP is working well for me, and that I find even at some scale, like even at the 300 million event scale, I typically find only a handful of new source IPs. Like in this case, there are 4. And possibly the best example so far is this is a persistence method that was just recently being talked about. There was research that was recently published on this, like last month, where there's an obscure method called get federation token, where you can create a federated user, and that federated user will survive and continue to function even if the original user that created it is disabled. And there are some limitations, so it only works in the console, and it's not supposed to work in the CLI, and it appears not to. But this is one way, apparently, of where people have been persisting, trying to persist or trying to avoid getting evicted. So when the original compromised account, like if somebody figures out which account was compromised and either disables it or deletes it or changes the password or whatever, this federated user will continue to function unless that is dealt with as well. And so that's interesting. So this is something that, in this case, this is an action that I don't see this action normally in most of the data that I've looked at. It's just not normally used. It's too obscure. So this is something that we could alert on. If we wanted to make a simple alert rule for this, I think that's completely feasible. The problem is that until last month, I didn't know, and I think most of us didn't know, that we needed to alert on this, because until last month, we just didn't realize, until the course of maybe the last 60 days or so, we just didn't realize that this was an evolving technique that people were using. So the great thing about new action for user is that the first result here from January 29th actually precedes the threat intel and the research on this. So it's one way of finding things, because often in the cloud world, we're looking for things that in in the cloud domain in particular, and in threat hunting in general, but in the cloud domain in particular, sometimes it's hard to find emerging threats because we know we need to be looking for emerging threats, but we don't always know what we're looking for, and because we don't know what's coming next. And so what I plan on doing with new is, right now it's a query that runs across whatever hot data exists, whether it's 7 or 30 days. What we plan on doing, though, is making that into an Airflow pipeline that'll run in the SQL database where this data lives. I'm using SQL today. And the Airflow pipeline will run continuously and essentially just rerun the query, looking for new actions for a user, new source IPs for an account, new this, new that, and it will persist that output in a table somewhere in order to have memory. So it'll become like a simple form of learning. And so as long as that is running, even if you only have 7 days of hot data, then the new function will still be able to reason about what things are new for as long as it's been running. But without having, so we potentially be able to find things that are new in the last, say, year or more, but while still only keeping 7 or 30 days of data hot. Because I don't know if you looked at data costs, but trying to keep hot data for a year is usually cost prohibitive. It would just be too expensive. So we still have about like 8 minutes of time, so I'll show you just to show you what this looks like. What I'm doing today is each card here is displaying the output of a SQL query. So at the top here, this first one is looking for users and roles coming from multiple countries at the same time, and this last card is looking for actions or transactions coming from an unusual geography. And then down here we have new action for a user, which some of that is interesting. We have a new actor for a key, and that has no output. And that's actually a good thing, because that's a case where kind of no news is good news, because nothing is absolute, but much of the time you see the same access keys using the same roles and doing the same transactions day after day. And so this is one case where it's actually not unexpected to not see output here, and in fact, having no output here is a good thing. Anomalous service activity is a user accessing a service so it's a case where there's a very small number of events for the combination of the user and the service. So a user is working in a service that they don't normally use, because again, most of the time, like day to day, most user contexts work in the same services over and over again, and they don't usually, day to day, there's usually not that much change. There'll be change in the long term, like over weeks and months as new projects start or new things are built. Sometimes you'll see users in new services, but on a day-to-day basis, it's usually not that much. And then down here, these are the top 5 surges or spikes by top 5 standard deviations. And these, when you take the top 5, the signal here is pretty good. Like signal to noise is pretty good, because when you take the top 5 here, these standard deviations are often in the thousands. You know, it's not like 1 or 2 or 3 standard deviations, which that would give us a mix of interesting and uninteresting, peaks and troughs. But the top 5 standard deviations are so large that they're usually interesting. And so you can see like one of these, or actually 2 of these error spikes are authorization errors, which means that, those are interesting because there really isn't a normal explanation for that one. Because if you've got a huge surge in authorization errors, like much larger than what normally occurs, then it's one of 2 things. It's either something is broken or it doesn't have the permissions it needs to do what it's trying to do, or there's somebody has persisting with credentials and they're just doing massive discovery and setting off authorization errors. But it's one or the other. There's not really a normal explanation for a huge flood of errors. And then same thing for events. Over here plotting the top 5 spikes in events by standard deviation. And you can see like describe volumes. This is actually being caused by automation. There's actually a script running PACU activities. So if you've heard of PACU, it's essentially a security auditing tool and pen testing tool for cloud environments. There's another one called BARC that's becoming more popular, but they're both good. But running either of those automation tools will typically generate an unusually large spike in events, especially for that user or that instance. And most of the time, unless, as long as you're not in a user context that has admin access to everything, most of the time, it generates a lot of errors too. The other interesting thing about a rare error is if you plot very rare errors or new errors, sometimes those will find subtle discovery or privilege elevation or lateral movement activity that is not voluminous, but it's very small, maybe somebody doing it by hand, will generate rare errors. Rare errors and new errors can also, I found, sometimes my SREs and folks use that because those will actually, sometimes we found, will predict a service failure is imminent, like a service is going to fail in the next few minutes. Often will be preceded by a rare or new error. So that is my talk, and we're pretty much on time, so I still have a few minutes for questions. Yes?
It sounds like you have a constantly shifting baseline. Is that dependent on the user, the machine, the egress? What are you valuing? And then on top of that, based off the events, do you actually apply a weighted factor? That way a combination of certain events may actually trigger where individually they wouldn't stand out?
Yes, so to both. So it is similar to a baselining function, especially like the new function, whether it's new action, new source IP, whatever, the new observable function for an entity is, you could call it baselining because as it runs, whether it's running just on 30 days of hot data or if it's been running long term, it's essentially learning what the normal baseline is. But it's learning what is unusual for a user context or an entity, and we can infer, by inverting that, we can infer that like anything else that's not showing up, for the most part, is probably normal baseline. And in terms of combinations and correlations, I think that actually may be a really promising direction, because a lot of the conventional rules tend to have really, really large output. A lot of rules here working on CloudTrail events, sometimes they have too many alerts. I think that combining different detection types together, looking for cases where different detection methods agree that some CloudTrail event pattern is anomalous, I think that that's going to be possibly the most promising way to do this. One of the things we're going to do next is, in order to do some more, so we're doing these anomaly detection techniques today, and those are working well. One of the next things I plan to try is, right now, it's really popular to create rules that act on kind of sequences of events or sets of events. When you say, we see these 3 or these 5 events for the same key within, say, 15 minutes. And those are kind of popular, and lots of people are doing those today. So over the course of, in the next few months over the summer, we're going to try applying a machine learning model to that. So rather than just looking for hard-coded lists of events, we're going to try applying a machine learning model to look for anomalous or unusual clusters of events, either sets or sequences, either way, anomalous clusters of events, in order to try and find which of those, in order to try and find, like, of those sets or sequences, which ones are actually suspicious. But other questions?
Can you tell from what you're seeing in the CloudTrail whether it's a new user or an existing user, like the age of the user based off of, like, as an indicator of anomalous events? So that you can tell if it's like somebody new doing discovery or if it's a new account that somebody's had created for them and they're trying to understand the environment they're working in.
Yeah, that's actually a good idea. So what I could get today is, if a brand new user started doing lots of transactions, then they might tend to show up in some of those new functions. But I think you're onto something there, and that I think that in addition to that, what I probably should do is create an event for create an event for, say, a create user, and not an alert on create user, because I don't want to alert on those because I don't want to bother, a lot of that's normal. But create an event for create user, and then basically do a join. So if I see a create user event, and I see that it correlates with either anomalies or rule-based detections, then yeah, give it a higher priority. The other thing I want to do is I'm going to plan to start either using a lookup table or a query to start reasoning about which source IPs actually belong to the organization and which ones don't. Because if it's coming from, if the call's coming from inside the house, if it's coming from another AWS account, then nothing's going to be unusual there. The source geography is going to be, whatever one of the 5 geographies that the regions are in. The source ASN is not going to be unusual. It's going to be AWS. Nothing about that is going to be unusual. It might tend to show up most of the time, it should show up as a new source IP, but in order to catch it there, in order to see it as new, you have to catch it relatively early. So one of the things I want to do is I want to start either labeling events labeling source IPs in the events, or that might be too expensive. So maybe just develop a query that either looks for alerts or detections from an IP address that is not associated with any of the accounts belonging to the organization. So it is an AWS IP, but it's not associated with any of your VPCs. And then possibly turn that into a detection, because there aren't that many normal cases for activity to be coming in from somebody else's account, unless it's a third-party service provider or vendor. But I think we could probably whitelist those. I think we could probably deal with those by excluding those.
So you're only going to be accepting unusual events from a new set of ASNs
Mm-hmm.
if you're onboarding a vendor.
Yeah, exactly. And once that happens, then those like the IPs of the internet gateways and their infrastructure could be excluded, and that will require a little bit of housekeeping because those can change, but they don't normally change, day to day, hour to hour. We would see, say, if a vendor account starts doing something it's never done before, or working in a service it's never used before, or if it starts generating a huge surge in, say, snapshot events or some other kinds of events or errors, I think that's one way of potentially, I think that the application here for finding unusual supply chain activity is as good as just finding, in-house activity. But I like I want to start kind of typing source IPs as self or not self, because anything that's coming from, if it's coming from an AWS IP and it's doing authenticated transactions in your accounts, and then if it's not coming from a vendor or service provider, then there's not really much explanation for that. And I think we're just about out of time. Thanks.